And right now we get to graph our first lines. We're not going to do this with slope-intercept form just yet. What we're going to do is actually plot points and connect the dots. This is going to be very simplistic, so you got to know what you mean when you're plotting points. This is kind of an important definition. This thing that we're going to call the graph of an equation. The graph of an equation. I want you to take care in this because you need to know what you're doing when you're doing it. The graph of an equation is a representation, and by representation we mean symbolic representation of all possible solutions. We have graphed before. We've actually graphed in this year without you guys realizing it. Like we talked about in previous lesson, when I have a number line and I graph this, and I do something like this, that's a graph of all possible solutions. It's a visual representation of x is greater than or equal to 0. So with that, let me show you an example, another example. If I have something like this, 2x minus 4 over x minus 2 equals 2, this has a very specific solution. I can get to that by actually doing a cross product, which you guys should more than realize by now. If you have two fractions that are equal to each other, their cross products are equal. So I get 2x minus 4 equals 2 times x minus 2. 2x minus 4 equals 2x minus 4. And that's the same on both sides. So what I mean, you don't have to go as far as adding 2 and getting 2x equals 2x. You should be realizing it right now, that this is always true. And since that's true for every real number, my solution would be all real numbers. But we know that x cannot be equal to 2 because of that divide by 0 problem. So my point is not to solve that, although I snuck a problem in there just because I can. My point is that if I want to graph x is not equal to 2, I'm going to put an open circle at 2. And let's stick an origin down, but I'm going to shade everything but that 2. And my big point is that this object here, this thing, that is a representation of x such that x is not equal to 2. And we're going to have representations now of things in two variables, and those are going to look like the classic two-dimensional graph lines that you have always come and loved. So, new definition. This is a more specific one. The graph of a linear, emphasis on the linear, equation is a representation of ordered pairs in a linear equation. So, if I get an example of a linear equation, I could have something like this. 2x plus y is equal to 5. And if I'm looking for possible ordered pairs, I could just kind of guess and check some, like 2 for x and 1 for y works, and 0 for x and 5 for y works. Now, when it comes to graphing lines, you only need 2 points. In fact, 2 points determine, and when I say determine, I mean give a unique one, but let me kind of explain this. 2 points determine a unique line. If I graph 2, 1 and 0, 5, there is only one possible way to connect those in a line. Just one way. And so 2 points are all that is needed to describe infinitely many other points. So what other points would we describe with these 2 points? Well, if I were to connect these points, and I actually have a line graphing tool, but I'm not going to use it right now for a few reasons, but, well, never mind. Let me go ahead and use it, and I'll cheat. It's really kind of, when it comes to this line graphing tool, I have to make sure I'm connecting the right points so I can actually cross through. You know, so I have to kind of extend that a little bit. That's not quite straight. That's better. But this is a unique line, and this line has the characteristic of having infinitely many points. There are points here, and here, and here, and here, and here, and here, and all over the line, infinitely dense. And this is a specific kind of representation of this. Now, this line was not drawn well. Let me try to recreate that because, sorry, I changed colors on you. As you can see, I have to make sure I click in with the correct slope. Okay, there we go. That's better. But 2 points to 2 unique line. All that is needed to describe infinitely many other points. Sorry, I need to finish this definition. All that's needed to describe infinitely many other points are only 2 points. So watch this. If instead of picking this point right here and this point, where I did, maybe I pick this point and this point, it's still going to give me all the other points. It's still going to connect and draw the same line. In fact, there are infinitely many points on there, but only 2 of them are all. That's all I need to draw this line. That's what we mean by a unique line. There are some features on this line that we're going to want to identify. This right here is called the Y-Intercept, and this right here is called the X Intercept. Let's go down here and describe this in a little bit more detail. We'll start with the Y-Intercept. The Y-Intercept is where the graph crosses the y-axis. And this is extremely important, and this should make sense to you. At the y-intercept, x is equal to 0. To find a y-intercept, let x equal 0. And we'll be doing that here in a sec. Let's kind of replace this all with the X-intercept. The X-intercept is where the graph crosses the x-axis. I want you to kind of off here to the side put also known as, or AKA, because the X-intercept has 2 other names. One of those is roots, and another one is zeros. And we'll keep reiterating that as well. At the X-intercept, y is equal to 0 since it's on the x-axis. And to find an X-intercept, let y equal 0. So we're going to do some graphing now, but I'm going to give you some very specific instructions. Instruction A, I want you to find the X-intercept and the Y-intercept. Now, this skill that we're doing right now, I'm going to star this one. You must know how to do that after this chapter intuitively and quickly. This cannot be something that you're constantly thinking about. X-intercepts mean set y equal to 0. Y-intercepts mean set x equal to 0. And they're 2 different points. B. Find another point if necessary. And we'll kind of hit an instance where it would be necessary, and you'll see what I mean by that. And then C. Graph and connect through all integer crossings. Meaning that wherever the line crosses an actual crosshair, we want to make absolutely sure that we have the line crossing through it. So, first example, we're going to do y is equal to 2x. A very simple one. Not a lot going on here. So we want to do part A. Let's find the x-intercept first, which means that y is equal to 0. So I'm going to take this equation and write 0 is equal to 2x. Well, at 0 is equal to 2x, if I divide both sides by a 2, I get 0 is equal to x. That means that when y equals 0, x is equal to 0. And that gives me an ordered pair of 0, 0. Now, some of you can see this, but if I want to find the y-intercept, I instead say y is equal to 2 times 0. I plug 0 in for x, and that would give me y is equal to 0 as well. But that makes sense because I don't need to say when x equals 0, y is equal to 0, because we just found that in the previous one. So if I start building a graph of what I have so far, I'm going to do this kind of off here. I have the point 0, 0. And that point's the origin, and that is the x and the y-intercept. In fact, sometimes, well, only that one time, your x-intercept and your y-intercept are the same. So we have to find another point, and that is part B. Find another point if necessary. So I'm going to take this and make a t-chart. I'm going to make it of x and y is actually equal to 2x. So if I say 1, then y is 2. If I say 2, then y is 4. If I say negative 1, y is negative 2. That's plenty of points. We only needed one of them, but I gave you 3. So 1, 2, 2, 4, and negative 1, negative 2. You can see the pattern, and I want you to continue that pattern. This is an up 2 over 1 pattern. So if I go here, and here, and here, and here, and here, that's plenty to graph, and then just take a line and connect them. That made sure we went through all major points. Now you don't need to make the points very dark. I just need to see a line going through that. It's important that, for me, your graphs are not dinky. That I don't want to see a graph look like this, where you have just like a little thing there. We need to see the entire graph, meaning like through every point that's given on that grid. Make them big rather than small. Do not cram into small margins of paper. Use lots of paper. I'd say please, but this is not a please thing. This is, you're going to do this. Number 2, 6x plus 2y is equal to 12. This is a line that we call standard form, and this is a kind of an important part of this. If I have something like this that's in the form of something times x plus something times y equals another something, we call that standard form. Now, strictly speaking, this isn't quite in standard form, because I could divide both sides, or should I say multiply both sides by a 1/2. I'm going to go ahead and do that. I'm going to take the left side and take the right side and multiply by a 1/2. Because whatever I do to the left, I must do to the right. And I'm going to use the distributive property, and I get 3x plus y is equal to 6. That's now standard form because it's in lowest terms. But what's the use of standard form right now? Well, if I look at my steps that I want an x-intercept and a y-intercept. X-intercept is where y is equal to 0. And if I plug 0 in, look what happens. 3x plus 0 is equal to 6. Divide by the 3. And I get x is equal to 2. It's really fast when you have standard form. I'm going to put that as an ordered pair. That is 2, 0. And then my y-intercept, I'm going to plug 0 in for x. So when that happens, I get 0 plus y equals 6. And that's y equals 6. And my ordered pair is 0, 6. Remember that at an x-intercept, y is equal to 0. At a y-intercept, x is equal to 0. So I'm going to take those 2 points, put them on a graph, see if I can pick up on the pattern of how this graph is going. 0, 6, and 2, 0. And if I were to connect those, watch this, I'm going down 6 and right 2. Well, that's the same as down 3 and right 1. I should have put a point there, and then here, and then here. I want to get the same ratio going. And then I'll just connect these. Now, I'd like your graphs to go a little bit further through. This line tool will only connect absolute crosshairs, so I'm going to have to stick in like a little ray here to cheat and make it look like I graphed the whole thing. There we go. Oh, that's the best I can do. I'll erase this and get it looking somewhat okay. You'll find I'm a little bit less picky than some teachers on the lines, but I want them to still be straight. I want them to be solid. I want them to be like use a straight edge, all that good stuff. So there I graph by intercepts. Let's do an example like this. Let's graph the line y is equal to negative 4. And you may ask, what? Well, watch. If I plug in what's the x-intercept? X-intercept occurs when y equals 0. That's an oops, because y doesn't equal 0. Y equals negative 4. So what that means is that there is no x-intercept. And, oops, let's do the y-intercept. Y-intercept occurs when x is equal to 0. Well, when x is equal to 0, y is still negative 4 because it says y is negative 4. So that's the ordered pair 0, negative 4. So for part B, I need more ordered pairs. So I'm going to plug in maybe 1, but I get 1, negative 4, 0, negative 4, which we already did, 2, negative 4. Every y is negative 4. And look what happens when every y is negative 4. 1, negative 4, 0, negative 4, 2, negative 4. They're all the same. It's a horizontal line. Graph it in a different color to make it clearer. There we go. That is a horizontal line. That is y is equal to negative 4. In fact, all y equals lines are horizontal. Let's go to number 4. You probably saw this coming. I'm going to do x is equal to negative 5. Okay, so when x is equal to negative 5, we're going to kind of go a little bit faster here. I just need points that have x as negative 5, like negative 5, 0, negative 5, 1, negative 5, negative 1. Just every point has negative 5 for x. And y can be whatever we want it to be. So when I plot this out, got a point here, got a point here, got a point here. In fact, I'm going to have points all throughout here. And we're just going to draw a vertical line. Like that. And that is the line x is equal to negative 5. And we can say all x equals lines are vertical. We're going to stop there, so you can go ahead and start this on your own.